We got here 5 sites and 2 hubs. And in each hub, there are redundant routers. Turkey is one hub. And in Turkey, we have R1 and R2 as redundant routers. And Egypt is another hub. Again, we have 2 redundant routers. See, this is very costly setup. This is very rare to see this type of setup. Usually we will have 2 hubs, but in each hub, redundant router is little costly. And each redundant router having separate ISP connection. You see, this is 110, this is 210. This is more costly. Only very rich company which is providing a big internet kind of service will afford to do this costly setup. So that's about the underlay. I can ping from this port to anywhere. This, all the WAN ports are reachable. For that, I am using OSPF. Let me show you that. I will go to router 1 and show you pinging the other sites. First of all, from router 1, I'll ping my own other WAN interface. Actually, it has to go via router 10, which is an ISP1. Router 10 is an ISP1. So if I need to ping from R1 to R2, there is no LAN connection so far. I don't have any IP address on this interface, so it has to go like this. Let me try pinging ping 210.210.210.2. I'm able to ping. If you want, you can see it will go via ISP. Yeah, it goes via ISP. ISP is 110, this one. 110, 110, 10. I'll also ping the other site. Like, let me ping the other hub site, which is Egypt. Ping 124.124.124.4. I'm able to ping 125.125.125.5. Let me also ping the spokes. Ping 71.71. Which is Saudi Arabia. Sorry, 71.71.71.7. I gave wrong IP address, that's why it's not pinging. Also 81, 81, 81, 8. Also 72. 72 will go via ISP2. This will not ping. The reason is you don't have a connection to ISP2. This is connection to ISP1. That's good. Okay, don't worry about that. You will not be able to ping because it is not right now routable. No, it should ping. Why it is not pinging? 72, no? 72 should be known to R1. Okay, again, I gave wrong IP address, that's why it's not pinging. 7. And also, I'll be pinging 81. 81, I think I already pinged 82, 82, 82, 8. 91, 91, 91, 9. 92, 92, 92, 9. Yeah, if you trace route, it will go to ISP1 and then it will go to router 9. To achieve this, I have one common OSPF. I'm not running two separate OSPF. I'm running one single OSPF. So this is possible. Otherwise, I need to do redistribution. Sai, do you have any question? This is basic configuration which is needed for our Dmvpn. So far, I have done only the underlay configuration. That's what I mean when I say basic. Do you have any question in understanding this? Sai, are you there? They are actually routers. I'm just simulating one WAN network, that's all. Any other question? I have not configured any of the inside network. These are all LAN networks in Saudi Arabia, in Oman, inside our organization. Those things I have not configured. Those things we are not going to advertise to the public. We will be advertising through the VPN. Those yellow marked networks will go through the VPN. And this is the VPN subnet of DMVPN1. This is the VPN subnet of DMVPN2. All right. So, Arul, do you have any question? All right. So, let us start with the hub configuration. We need to configure next hop server, NHRP, NHRP network ID, and tunnel ID, and the IP address of the tunnel. So, on router 1, I'm going to say interface tunnel 1. You remember we saw earlier when we learned this, I told we will be having this as a spokes to DMVPN1, where for DMVPN1 this is the hub. And for DMVPN2, we will make this as a spokes for DMVPN2, and this will be the DMVPN2 hub. Don't forget that. And in this sites, we will have two DMVPN, one DMVPN1 via tunnel 1. Tunnel 2 interface will be DMVPN2. So I'm going to dedicate the tunnel 1 on every router only for tunnel 1. Tunnel 2 for DMVPN2. Tunnel 1 is for DMVPN1. That will avoid confusion. We need two tunnel interface. See, I'll repeat what I said. This is going to be hub. At the same time, this is going to be a spokes for second DMVPN, tunnel 2. So we need two tunnel interface. Likewise, this also needs two tunnel interface. This one, for redundancy, I have two hub. Not only, sorry, in one hub, I have two routers for redundancy. Additionally, I have another hub also. So I need two tunnels, one for hub 1, another one for hub 2. So in every router, we are going to have two tunnels. If it is DMVPN 1, which is left-hand side hub Turkey, I'm going to use tunnel 1 number everywhere. If I am going to associate with Egypt, I'm going to use the number 2. So this is to DMVPN, this is hub 2, and also it is site 2. This is hub 1, DMVPN 1, tunnel interface also 1 on every router. Is there any question on this? On the spoke side, if you want to have two routers, same like what I have in hub, uh, then it will work. Then also it will work. What is the question? Okay, two router. Why you want two router? When I have two redundant connections, you see, I already have two redundant ISPs, right? If the router goes down, then the problem is these are all WAN connections, right? Then you need four WAN connections. Or you can take the second connection and put it into another router. The 72 network, no, you can put it into another network, sorry, another router. And between the 7 and the 2, 7 and let's say 7 and another router, you need another subnet and you need another protocol. Then that will be like an ISP scenario. But this is an enterprise, this is a site. Even this itself is costly actually. I don't think someone will be able to afford that what you ask for. It's between 7 and if you have another, you have seen? Okay. See, in hub you can, okay, you're going to connect this one here, right? This link here, correct? This link here, that I agree. But what will be the connection between 7 and 12? Will you have a connection between 7 and 12 or it will be only through the LAN? If it is only through the LAN, I have no problem. See, if it is then it is okay. Like this. If it is connected like this, then through LAN, someone, if R7 goes down, they will go via R12. Okay, you want me to put like this? Oh, then I need to add three more routers, six more routers. All right, let me do the alteration. So I need one more router. But what way it is going to be? I don't think it will be a difficult thing for you. It's going to be normal routing concept. No DMVPN in picture here. Yeah, because see, I don't see anything related to DMVPN when we change this. It is going to be only basic routing. If this goes down, R13 is going to forward to 12. That's all. And in R7 you will configure tunnel 1. In R12 you will configure tunnel 2. That is what the difference is going to be. Yeah. So it's not really security, Arul. What do you say, Arul? It's only routing. That is also there again. Yes. Okay, so let's not get into those areas. Let's focus on DMVPN. But it's okay. If it is two separate connections, then okay. Two ISP on each router is more costly. Two ISP on each router will be more costly, but you said it's not like that. Then it's okay. Now let us get into hub configuration. See, a lot of configurations need to be repeated, so I'm going to use first let me use one on router 1, and then I'll cut and paste on notepad and I'll do the alteration to the rest of the routers. So this is the configuration that will go on. Okay, R1, where is R1? interface tunnel 0, tunnel IP address is going to be 10.10.100. For the tunnel, I'll give 100.1 on router 1, 255.255.255.0. Tunnel mode GRE multipoint. Tunnel source is F/0. All right, next is tunnel ID, tunnel key ID is 1. And then, wait, let us finish all the tunnel configurations. Tunnel, starting with tunnel. Tunnel, is there anything important in tunnel? Tunnel source, tunnel. MTU, instead of MTU only, we are syncing the TCP packet, no? Anyone you can use, either MTU or we can make the payload to be smaller. Yeah, you remember we saw a command. Where is the word file? Yeah. This command is going to compress the file, not compress, it is going to make the file size, payload size as 1360, so that there is no need for fragmentation. All right, so we have finished tunnel key, tunnel mode, tunnel. Okay, that's all. Now I'm going to go with this command ipthcp adjust. iptcp adjust. See, the transit packets are going to be adjusted to the size that I'm going to set. See, tunnel interface is using a physical interface. So because there is an additional encapsulation, we cannot send the packet with the normal size. I need to prepare a packet in a small size so that additional encapsulation will not make it as oversize. So we need to set a size, and it is recommended to have 3260. Is it right? No, not 2. Yeah, 1360. 1400 is the actual size. 1400 for the physical interface. 1400 is the actual size, but we are shrinking it to 1360 so that the additional encapsulation will not make the packet bigger than 1400. That MGRE, that multi-point GRE. Fine. Next is all NHRP command. IP NHRP. First, I would like to go with the network ID. 1 for tunnel 1. IP NHRP authentication. I would like to give password as tunnel 1. Tunnel 1. Okay. Authentication string exists 8. Okay, I'll say tunnel 1. Same password I have to give everywhere, and we know that. Next is IP NHRP multicast. IP NHRP map command. I'll go map command. Map multicast dynamic. Okay, multicast dynamic. IP NHRP map. No. And then after multicast dynamics, tunnel IP is already given, source is given, interface is given already. This is done, this is done, this is done. This is the optional one. This is optional. Finish. enough. These two are optional. Yeah, those things are already done. All right, let me show you what is already done. Um, show run interface tunnel 0, sorry, tunnel 1. See, okay, no redirect is the default. Let me make it as IP NHRP redirect. Okay, so any update comes, it will forward it to the other spokes. Any NHRP discovery packets, those things. So show run interface tunnel 0 and 1. Okay, so I'm going to just copy the same to a notepad and do some alteration to all the rest of the hub router. Tunnel 1, this is going to be 100.2. This is not needed. I'll remove this. Authentication tunnel 1, dynamic. What is the interface name? Same 4/0. That's it. Nothing more. This will go on router 2. All right. Next is R4 is also going to be a tunnel, but there is another Dmvpn, no? So I'm going to give different number. Tunnel 2. This is going to be 200, and that is router 4. So I'll say 4 here, and all the rest are same. See the physical interface also same, F4/0. But the tunnel network ID should be different. So I say 2. Tunnel keys also should be different. I say 2. So for Dmvpn 2, I make all 2. Nothing other than this. So let me put it on router 4. Done. Similarly, router 5. Yes. For every tunnel, the NHRP ID is local to the tunnel. That is right. That's right. Yeah. Mm. No, don't have. What is wrong in giving two different numbers to avoid confusion? Keep it different. That's a good practice to keep different number. See, the negotiation of NHRP uses this ID. You are talking about tunnel ID or tunnel NHRP ID? Network ID is no, it's not local. Where did you read local? NHRP uses this to negotiate. No, it's not local. It should be unique. All right, now this is going to be on router 5. Next is the authentication key. I did not change there. I'm using the same authentication key for both. It's okay. It's just a password. All right. But good to use different passwords, but I'm using same password. I finished pasting, so I don't want to change it. Is it okay, or you want me to change? Should I change the password or should I keep it same? Doesn't matter. Good. Right. Now, this, yeah, the spokes configuration. Let us start from R7. No, instead of R7, let us go to R1. No, let's go to R4. R4 and R5 should be spokes to R1 and R2. Let us configure that part. So this is going to be tunnel number 1 on same R4, and this is going to be 100.4, and the password is same. IP NHRP multicast, it is not dynamic. IP NHRP multicast, where should it send? It should be sent to the public IP address. The public IP address. Let me do it on one spokes configuration, and I'll do it on the command line. And then we will go to the notepad. Interface tunnel 1. IP address of the tunnel is 10.100.4. And next is IP this tunnel mode multipoint GRE multipoint. Tunnel ID is 2 for this. Tunnel key ID is 2. Is it 2 or 1? 1 for this. On GRE1 we are talking. So for GRE1 we are making R4 as a spokes for synchronization between the hub. And then tunnel interface is F. Tunnel source interface is F4/0. And then what? Tunnel, IP NHRP. IP NHRP. Network ID is 1. IP NHRP. Multicast IP NHRP. Map command will do the mapping before that. Okay, authentication also we have to finish. What is the authentication we gave? What's the password we gave? Tunnel 1. IP NHRP. Multicast. Map. Multicast. NBMA address, which is 1.1.110.110.1, and also one more multicast address, one more NBMA address, which is 210. No, we have redundant hub, right, in site 1. You understand what I'm doing? See, R1 is not the only hub in Turkey. R2 is also a hub, no? So what I'm doing is right or not? Let me show you. In the document where I explained you see here, if you go to the spokes configuration, look at this. This is what I'm doing. Yep. All right. So we had to do two configurations because you got 2 hub routers on each hub site. Redundant hub on each hub sites. Right, so we have finished this, we have finished this, we have finished this, and then this is, this need to be done here. We have not done this here. This need to be done. These things are done. No, yeah, these two we need to do, and these two we need to do. That a tunnel IP address to public IP address mapping need to be done. IP NHRP map. First the tunnel IP address, which is 10.10.100.1. If I need to go there, which NBMA address I need to go? This one. Likewise, IP NHRP map 10.10.100.2. For that, the public IP address, the WAN IP address is this. Next, IP NHRP next hop server is this one. IP NHRP next hop server is this one. What else I need to do? IP TCP 1400 is the default size, 1360 is what we are giving. Did I miss anything, Arul? Okay, let's check once for our one interface. One. This is the IP authentication to redundant hub tunnel key. Looks sounds good. Let me quickly compare this with the document which we already have, so that there won't be any surprises. Okay, authentication is there. There's three, two things are there. Network ID is there. Hold time and all not necessary. IP NHRP shortcut we can use to use the shortest route, but again optional one. This is okay. This is okay. This is okay. This is okay. Perfect. Okay, so now next is what I'm going to do. I'm going to just cut and paste, copy this to a notepad. And I'm going to only change the IP address. The IP address on router 5 is going to be 5. So two tunnels we are finishing on Egypt. One is the hub configuration, the other one is the spokes to the Turkey. R5. IP should be 100.5. Let me check. Yes, right. See, we are forming association with tunnel 1. For tunnel 1, this becomes a source. See, for tunnel 2, it is 200. For tunnel 1, if I need to associate with tunnel 1, I need to be in that subnet 100, no? Yes? Okay. Yes, yes, yes. Okay. So we got the tunnel configuration. According to R1 and R2, R4 and R5 is also spokes. Show IP NHRP. Look at this. It's already there. Already 2 hubs discovered. Now what I'm going to do is I'm going to do slight modifications like IP address changes and put it on 7, 8, 9. For router 7 there's going to be 7 here. All the rest are same. No difference. Only the interface will change. Interface is going to be F0, 0. This interface. Alright, so Arul, do you follow? So is your voice breaking? Do you follow? Okay. So Arul, do I need to do any changes here? Nothing. Select all, copy, and this goes on R7. R7 is done. Next is R8 is going to simply have 8 there. And I need to check the interface name now. Okay, that is also F00. So can I copy and paste? Will there be a problem? No problem. You're right. And also I'll do changes to the notepad like .9 so that I can paste it in 9. And what about the interface? It is F00. So no changes, select all, copy. This is going on router 9. So the tunnel ID is locally significant. Last time when Sai asked question, I was thinking that you are talking about the tunnel ID. Yes, tunnel ID is locally significant, but network ID is not locally significant. It's global. Now, next, I must have now NHRP neighbors. Show NHRP. It shows 2 spokes, sorry, 2 hub. But you know, I can also have reachability to all the spokes. Let me show you that. I can ping from here .5. You see? Now you can see the map with 5, 9. I can also ping .7 and 8. Now you can see the map grown bigger. So through the hub, I have learned all the other spokes. And you see all their public IP addresses are dynamically learned, the WAN interface IP address. So Dmvpn is already working, 1 VPN is already up. Now let's focus on the second VPN. I'll start from router 1. Router 1 is a spokes to Egypt. So the notepad, I want to alter like this. So this is going to be 200 and this is going to be tunnel 2. It's a separate tunnel interface. And this will be 1. IP NHRP map 200.4 124.4 and 200.5 125 The multicast packets need to be sent to those public IP addresses. This one, this one. And then NHRP servers means next up servers or this one and this one. Wait. And then the interface that needs to go out is F4/0. I don't think, okay, the key ID should be 2. Very important. That's it. R1 over. Now, this time I should see the hub actually. Show IP NHS. NHRP for tunnel 2 only I want to see. See, 200.4, 200.5, they are in tunnel 2. It's already in use. The registration happened, over. Which means our configuration is neat, so let us continue with the other router. This is going to be 2. There's no difference in this, there's no change in these things. What about the interface? Interface is F4/0. That's all. Other than IP address, is there any need of any changing anything? Nothing. Harold? No. Copy. This goes on router 2. All right, so we need to again create a second tunnel on other routers R7, 8, and 9 for redundancy. So R7 is going to have .7. And this interface is same. There is no change and nothing more. Copy, paste. R7 is done. R8 also I see the same interface name F4/0. So I do only changes in the server, the IP address, the host portion. Rotate. And then router 9. Same interface, no? So 9. Over. It's over. Right? So the Dmvpn is ready. Next is the LAN networks need to be advertised through the Dmvpn, through the tunnel. LAN networks we will first configure and then we will advertise it. I'd like to start from router 9. All are going to run one EIGRP only, common EIGRP called Autonomous System 100, everywhere in all 5 sites. The LAN interface and the tunnel interface. Tunnel is the one which is going to connect between the LANs of all the sites. So the overlay and the LAN will be running EIGRP. I'm on router 9. I'm going to say router EIGRP 100. Networks or 10 networks. If I say 10, you know that is enough. Because the tunnel IP are also 10 in the first subnet. The LAN is also 10. No auto summary. Finish. This is exactly the same configuration that you are going to put it on all the sites. Nothing more is needed. You can configure stub optionally to say I would like to advertise only the connected and the summary routes. That you will do only on the R1, R2 and R4 and R5 because it has got some internal router like R3. Whereas in these sites like Saudi Arabia, Oman and Sudan, there is no internal network. So those things are routing concepts. Do show history. I'd like to copy this and paste it on every router. Router 9 is over. Let me go to router 8. Router 8, router 7. And there is no EIGRP on the ISP. There is no EIGRP on the WAN interface. Only on LAN side of the sites we have enabled. Let me go to router 1 and repeat EIGRP. Router 1 and router 2. Router 4. See via tunnel you can see the adjacency already there. Router 4 and then router 5. Now what is left is we need to just bring the LAN networks. I would like to start from router 9. I have not configured those loopback interface. Just to simulate inside network, I'm saying interface loopback 0. 10.10.99. IP address 10.10.90.9. 255.255.255.0. Interface loopback 1. 10.10.91.9. Now these routes will be available on every spokes. I can show you on router 1 now. Router 1, if you go to routing table, show IP route EIGRP, you see 90.0 and 90.1.0. These two are learned via the tunnel 1. Now this is also learned via tunnel 2 in R4. Go to R4, show IP route EIGRP. You see, via tunnel 2. This shows the redundancy. Redundancy between site Egypt and site Turkey. Same network learned through 2 different tunnels. Here tunnel 2 is the hub, there tunnel 1 is the hub. Let me go to router 8 and finish the LAN configuration. 10.10.80.8 interface loopback 10.10.80.1.8. Again, this is also available now on R4 via tunnel 2 and in R1 via tunnel 1. Likewise, router 7. Ten ten 70.17. Oh my god, what I did. I made a big mistake. This is tunnel 0. There is no tunnel 0, it's loopback 0. Good that I said tunnel 0. No interface tunnel 0. We have only tunnel 1 and tunnel 2. Good. Interface loopback 0. 10.10.70.7. Interface loopback 1. 10.10.71.7. And I'm expecting these also on R4 and on R1. Wonderful. So the hubs also got some subnets so that R3 can ping the other site local area network as well as R6 from R3. For that, I need to configure R3, R1, R2 LAN, R6, R4, R5 LAN. Let us start from R1. Interface loopback